Hello. In this video we're going to take a look at section 5.3 of the book, which is your introduction to algebra. Now if the A word scares you, you're not alone. A lot of people have terrible memories of having to solve algebra equations in high school. But don't fret. The equations that you're going to solve in this question are all fairly straightforward. The most important thing to remember when solving algebraic equations, or linear equations as is the case in this section, is to make sure that you show all your work clearly and write everything out step by step. I can't emphasize this point enough. Most of the times when people have difficulty with algebra, it's because they try to do too much in their head or they try to skip steps or mush steps together. It's really critical to make sure that you take things one step at a time. You can't deal with algebra problems holistically. You have to break them down into discrete steps, and we're going to go over the steps in this video. The human brain can only hold something between 5 and 7 pieces of information in your short-term memory, and some algebra problems, not the ones in this section, but some of the ones later on, are going to have something along the lines of 18 steps. You just can't do that in your head. You have to write things out, and you have to make sure that you show all work. So what you're going to want to practice with this section is showing your work clearly and making sure that you take each step one step at a time. Let's go ahead and take a look at the equations here and make sure that we understand the steps for solving them. So solve the linear equation, taking a look at this first one up here. 43 plus x equals 18. Well, the first thing to understand about an equation is that that equal sign is the most important part of the word equation. The equal sign is the center of your equation, and it splits it into the left and right sides. When I'm solving equations, I like to actually draw a little line down the middle where the equal sign is, and I encourage you to do that too when you're writing your work in your notebook. That's kind of hard to post on the class website when you're posting your homework solutions, so you don't have to put the line there, but I do strongly encourage you to write it when you're writing things out. So as I said, this splits my equation into the left, and yes, I'm actually going to write this just this once, and the right, which is super important because I'm often going to say things like, make sure that you do this on both sides of the equation, or whatever you do to the left, you have to do the right. And what I'm talking about is left of the equal sign and right of the equal sign. So that equal sign is your middle. Make sure you draw the line when you're showing your work. So our first step here is to identify the number and operation that's on the same side of the equal sign as x. This equation is sort of like a sentence in English. It's telling you something. It's saying, hey, I took 43 and I added some number to it, and I got 18. That x, as scary as it looks, is just a number. It's called a variable. It's a number that we don't know, and we use a letter to represent it. And your goal is to try to figure out what the heck that number is. So in order to do that, you've got to figure out what x is equal to. Well, I know what 43 plus x is equal to, and that's not going to do me any good. I have to get rid of this 43. So my first step, I'm always going to look at the number that's on the same side of the equal sign as your x and identify what that number is and what mathematical operation is going on between that number and x. In this case, the number with x is 43, and it's being added to x. So my next step, I'm going to do the opposite operation with the exact same number directly underneath on both sides. Whoa, that's a lot going on there, so let's break that down. I'm going to do the opposite operation. Well, this 43 has a plus sign between it and the x, so it's being added to the x, but I do have to be careful and pay attention to what the sign of the 43 is. Since it's positive, I would be adding it. So I want to cancel out that positive. There's no sign in front here, right? That 43 has nothing in front. So that means I'm going to cancel it out with a subtraction. And I'm using the same number, 43. And I'm going to write it directly underneath the original 43. So I'm going to write minus 43 right under here, directly underneath. So I did the opposite operation. The opposite of an addition is a subtraction, with the same number, 43. And then I'm doing it directly underneath, but I also have to do it on both sides. So I did it on the left. I'm going to do this minus 43 on the right as well. Things always have to balance in an equation. Both sides have to be equal. Whatever you do to one side, you have to do to the other. I have a 4-year-old at home, so I like to think about this in terms of toddlers. When she has a friend over, if I gave one of the friends a little unicorn toy, I better make sure that I give one to her too. So if you're giving one of the sides a negative 43, make sure you do the exact same thing to the other side or they're going to fight over it. So what happens next? Well, now I'm just going to evaluate going top to bottom. 43 minus 43 is 0, so they cancel out. You don't have to write the 0. 43 minus 43 just leaves you with nothing. All I have still on the left side is this x. So I'm going to bring it straight down. X is going to go right here. I'm going to bring down my equal sign as well. And then evaluating on the right, I have 18 minus 43. Well, be careful here. The signs are different, so you do indeed subtract. And when you subtract, you're going to make sure that you keep the sign of the larger number, which is negative. So I'll have 43 minus 18. I have to flip them over, or you can punch this in a calculator too. I'm going to do it long ways just for fun. You can borrow here, and I'll do my 13 minus 8, which is 5, and 3 minus 1, which is 2. That 5 looks like a 6. My apologies. So that should leave me with a negative 25 as my answer here. So paying attention to the sign rules from section 1.9 is also super important because those are going to come up quite a bit when solving equations. So I'm left with x equals negative 25. All right, let's take a look at the next one here and see if we can do the same thing. I have 12 equals x minus 9. Now, things switched around and got rearranged a bit for this one, and that's okay. I can still follow through the same step-by-step process. I'm going to look at the side with x and identify the number and operation on that same side. Well, let's split this down the middle where the equal sign is. My equal sign is my middle, and x is on the right side this time, and the number on the right is this 9. Because there's a sign between the x and the 9, there's that minus sign there. This is a subtraction. Could be an addition or a subtraction depending on what all the different signs are. But I look to the sign to the left of the 9 and it's negative, so I think of this as a subtraction, and I'll cancel this out with an addition, with a positive. So directly underneath, and I want to cancel that exact same number on the same side as x, the 9. Now, don't forget to do it on both sides. I did it on the right, so I'm going to have to go back over to the left and do it there. Plus 9. All right, and now I can evaluate going top to bottom. I like to color code things here. 12 plus 9, well, that's going to give me 21. I'm going to bring down my equal sign. Now this x is still here. This x is going to come straight down. And now negative 9 plus 9. When I take my negative 9 and I add 9, the signs are different, so I have to subtract them. When I subtract, I get 0, so those cancel out. That was the whole point of adding 9, was to cancel out the minus 9. So that leaves me with 21 equals x. Well, I found out what x is. It's 21, and so that's my final answer. As long as you have x alone on one side of the equal sign and a number on the other, you've got your final answer. It does not matter which side x is on. So 21 would be my answer here. Let's take a look at the next one, 3x equals 51. Well, this involves a new idea. Whenever you see a number just touching the x, there's no sign between that 3 and the x. It's just touching that x. That's understood to be multiplication. That means 3 times x. So I'm going to have to cancel out a multiplication here, and I always do that with division. That number that's in front of the x, that's touching the x, by the way, has a name. It's called a coefficient. That's going to come up again and again throughout the class, so it's a good word to learn. So let's see if we can work this one out. I'm going to have to cancel out the number that's on the same side as x, and that number is the 3. So I'm going to put my 3 underneath. And now I'm not canceling out an addition or a subtraction here, since that 3 is touching the x. It's understood to be multiplication, so I'm going to go ahead and divide by 3. And the way we do that in algebra is typically to write a fraction bar for division. You can use the old school division symbol, and that's fine, but the fraction bar is actually pretty helpful for reasons that will become apparent later on. And I want to make sure that I do it the same way on the other side. I'm going to write my divided by 3. And now again, I'm going to evaluate top to bottom. Well, 3 divided by 3 is 1, and that's considered to cancel out. I have 1x, which means I just have x over there. And that means I can bring my x down, and you notice that we always do that. We bring our x straight down. Oh, I forgot to put my line. I put my equal sign, and then 51 divided by 3. If you punch that into your calculator, or if you do it longhand, you'll see that that's equal to 17. And so my final answer for this one, I've got x on one side of the equal sign and a number on the other side. So that means x equals 17 is my final answer here. All right, there's one more question here. And this one's a good one, so I'm going to encourage you to try to hit pause here on the video and see if you can work this one out on your own. Make sure that you're following the steps exactly as they are, step by step. And don't cheat and try to skip steps or do it in your head. Trust me on this one. Go ahead and hit pause and try it out, and then we'll resume and see if you got the same answer as me. Okay, are you ready? Did you get an answer? This one's a little bit tricky, and I did it this way on purpose, so let's take a look. I'm going to put my line here, and we're going to go ahead and try to cancel the number that's on the same side as x. Be careful here. It's really easy to look at this one and say, oh, hey, that 20 is touching the x, so it's multiplication, and I have to divide. And without actually showing your work, just do 20 divided by 5, which is 4. It feels right, but that's not the right answer. When you divide here, you have to divide by the number that's with the x. I always, as you can see in step 2, I'm always doing the opposite operation with the same number, meaning the same number that was with the x on the same side of the equal sign as x. So the number that's with x is 20. And I'm going to put that 20 underneath on both sides. And it's going to be divided by, with that fraction bar again, I'm going to do divided by here again. So it'll be divided by 20 on both sides. Now, make sure that you evaluate top to bottom, as it says in step 3. That means when you're punching this into your calculator, if you do it that way, it's going to be 5 divided by 20. If you're doing long division, you have to flip those around. But the long and short of it is 20 doesn't go into 5, at least not a whole number of times, so you won't get a whole number answer here. This isn't 20 divided by 5, it's 5 divided by 20. If you have $5 and split it up amongst 20 people, people aren't going to get more than $1, certainly not $4. In fact, they'll get 25 cents. So 5 divided by 20 will give you 0.25, or 0.25 if you'd like. And that's going to be your value for x. The 20 divided by 20 is going to cancel out again. And you can just bring down your x. So that one was a little bit tricky because if you do it in your head, or if you think you know what you're doing but you don't actually write all the work out, it's very easy to accidentally divide in the wrong way. Make sure that you write out your work so that you divide things in the correct direction. Alright, to summarize, solving equations from section 5.3, these are all what are typically called one-step equations because you're going to be solving them in one phase, even though that is split up into 3 different parts here. You're going to identify the number that's on the same side as your equal sign as x. Figure out what that number is that's with the x and what operation is going on with it. You're going to do the opposite operation with the same number directly underneath on both sides. So cancel an addition with a subtraction with an addition, and a multiplication with a division. Once you've written that underneath on both sides of the equation, make sure that you're evaluating top to bottom. The number that's on the same side of x should cancel out, but the other pair of numbers should give you your final answer.